Alrighty, so let's get started. Any questions about anything we did last time? Any of the assignments? Anything at all?
You have 7 days for the assignments, right?
You have 7 days after the assignment was assigned, and yeah, that's the due date.
Good.
Okay? Any other questions?
I just want to clarify, we're downloading it as a CPP file and then we're sending that CPP file
You're saving your program, your CPP. If you're doing this on Windows, it's going to make 3 files. One is going to be a .o file, one is going to be a .exe file, and the one where you write the code is going to be the .cpp file. You're giving me the .cpp file.
We put all that stuff in and we send it to you just in an email?
Yeah, you just give me the CPP file. I don't need the .o. I don't need the .exe. If you give me those, I can't see your code, and I will give you 0. So you got to give me the CPP file.
Okay.
Okay, good question. Yes, sir.
How many submission attempts do we get?
Well, 2 submission attempts. So you do it. You can turn it in one time. Each assignment, you can turn it in. If it's not correct, I will tell you, okay, there was something wrong with this. You look at the feedback, and then you have your second submission to resubmit that and get a full credit. But I don't want to do it more than twice per assignment.
His question's a little stranger. He saw a typo after he submitted.
Uh-huh.
So can he just resubmit? Can he
Oh,
fix the
yeah.
typo and
As long as I have not graded it yet, you can resubmit the thing as many times as you want. I'll go off the last one you gave me. In Canvas, you probably will see a bunch of files that you uploaded. Let's say you have one assignment, you did it wrong, or you noticed, and then you resubmitted it, and maybe you corrected it again, and you resubmitted it. Maybe now you have 3 files. I'm going to see all 3 files, and I'm going to go with the last one.
Okay.
And then after you do your grade, when I do the grading, then you get another resubmission on that. But before I do the grading, you can submit as many times as you want. I'll just go with the last file you gave me. Yeah? Yes, sir.
Is there something we're supposed to do to get into the Wi-Fi with our own computer?
To get into the Wi-Fi, you're going to go to ic.gavilan.edu. It's right here on top. ic.gavilan.edu, and then it's going to ask you to enter your student ID and your password, similar to this stuff here, and then you can use the wireless on campus. Okay? Yes, sir.
For the extra credit, do you want us to turn it in as a Word?
Word file, yes. There's a couple of extra credits. These were these 2 first ones here. Please turn them in as just a Word file or a text file.
Okay.
Yeah, anything that works. Awesome. I love questions. Anything else? Okay. So last time we talked about input, output, processing. Right? We did some examples of that. The different data types. I have like a little review thing here, so let me click on that so I don't have to type things again. All right, see what I have in there. Okay, well, no, let's not do that. I'll go off the previous one. Okay, so just to point out to you, these are the lecture notes that I did last time, and there's the video that I did last time. So I'm recording myself right now, and everything I'm typing, I'm going to post. I'm going to post the video later. Okay, so let's have a look at what I typed up last time. Okay, so I'm just going to download this thing. All right, so for me it opens up in Sublime. This is a Sublime text editor. It's a nice text editor, so let's just go through this real quick to see what's what, and then I'll switch to code blocks. Okay, so first of all, every program that you have, remember, has to have these comments on top: the program number, your name, the date where you started and finished this thing. If you started and finished on the same name, put the same date. Description. The description, usually you can copy from the assignment itself, and if it's a long description, you can use multi-line comments, which are the /*, */ and then just copy the description from the assignment and throw it right in there. And why would you want to do that? So you don't have to go to the web page to look at what you're supposed to be doing, so that when you open your program later on, you know why you did what you did. Okay? And Those are the multi-line comments. And at the end of each of your programs, you're supposed to include how the program ran. Right? So this is not how the whole program ran, but just in a little example. Every program, when it's done, copy the output, paste it at the bottom to show me how it tested and that it works. Okay? All right.
You just want just the output, not like any additional description or...
You can throw in anything that's in the output. So for example, in C-Lion, whatever you see on the bottom in C-Lion, you can copy all that and throw it in there. That's fine. Okay? All right, so I'm going to go back to Sublime. All right, so again, everything with 2 forward slashes is considered a comment. What is a comment? Comment is an explanation for your code. It does not really count as programming instructions. These 2 lines include IOStream using namespace std. Every one of your programs is going to need them because every one of your programs is going to do some kind of an output. So in order for the cout to work, you got to do this. Okay, if your file name, that was like one of the common mistakes, or it has been throughout the years, if you fail to save your file name with CPP extension, code blocks will try to save it as a .c file, then the program is not going to work because the C file will not be able to work with these 2 lines. Okay, so C is the older language, C++ is the newer version of the C language. Okay, so it's not forward, I mean, the older one is not compatible with the newer one basically. You have to save it as CPP. Okay, this part here, the int main, is where your program starts. Every one of your programs that you're going to be running, which is every one of them, it's going to have that also. And that's about it. And then at the end of that whole thing, you close the curly brackets, and that's the end of the main. Okay? After that, whatever's inside of the main should be indented. Notice how everything is lined up, certain number of spaces from the wall. It's all the same number of spaces. You don't do this kind of stuff, right? It's hard to read, that kind of code. Okay? If I see that kind of chaotic indentation, I'm going to take points off. I'm going to tell you, oh, look, this is bad. Just fix it. And again, you can resubmit it and correct it, no problem. Okay? So the reason for this is later on when your programs start getting more complicated, there's going to be further things that are getting indented. So certain lines of code are going to be indented here, certain other lines of code are going to be indented there, but we're not there yet. Okay? So indentation is important. Comments throughout your code are important. You're not going to get graded on these comments unless it's one of the sample assignments that asks you type up everything, including these comments. I do that in the beginning so that you know what these early programs are doing, so that you can look at your code and you know what you're doing and how things are working. Okay? Output refers to information that comes out of the program. The way we do output in C++ is using cout, less than, and then something else after that. Okay, this example right here is an example of output of a string. What's a string? Anything in quotes. Okay, other than a string, there's other types of information or data types, such as character, integer, float, double. Okay, so this is an example right here of a variable called myname. And that variable is of the string type, and it's equal to this particular string right there. Okay? What is a variable? Variables are just words we make up to store information. Right? Variables are just words we make up to store information. There's a few rules for these variables, and I forgot to mention that last time. So I'm going to throw that in there today. So why don't I go back to my C-Lion, right, which is where I'm going to write this for today. So some rules for the variable names, which is in the web page also, but I'll put it right here. So rules for variable names. Okay, so the first thing is can't start with a number. Okay, so if I go in there and let's say, all right, string name is equal to Alex, right? And let's do a little output. So cout name and del is to show a new line. If I run this thing, All right, there you go, Alex. Okay, but if I go in there and I do this, put a number in front of this, code blocks, I mean, C-line is already complaining, code blocks is not going to detect that until, until you try to compile your program. So let me try to run this thing here so you can see what the kind of error the code blocks will give you. And the error is, error expected unqualified ID. Basically, you can't have a number in the beginning. Okay? So I can put the number in the middle. I can put the number at the end. Right? That's okay. The only reason it's complaining here is because now this name variable does not match this one, so I can copy paste it there, and now it's happy. Okay? So that's the first rule. Can't start with a number. The second thing is, let's say I have something like first name, right? That's going to be my variable name. I'm going to paste that in there, copy it, paste it. Okay, so first name, it's okay. It's two words connected with the next word is with a capital letter. Okay, so that's one way to do it. It is not okay for you to put a space in there. Okay, no space in variables. So that's the second rule. Can't have any spaces, right? So no spaces. How would you connect different words? You can capitalize every subsequent every subsequent word's first letter, or you can do underscore, right? Underscore is allowed. Okay? And underscore is the only special character that you can have in your variable names. So the third rule is no special characters like, I don't know, any of these on top, right? Except the underscore. That's the only one that works. Okay? So that's that one. Other than that, C++ also does not allow you to use reserved words. So I can't go and use, no reserved words like using, some of these words that are in orange, those are reserved words. Okay, like the include also, the IOStream also, right? So don't use those, right? Also like say cout, right? You cannot use these words for your variable names. Okay, that's that. And then the last one is really it's not a rule, but something you should do, right? Use meaningful variable names, right? So if this variable is going to hold the value of a first name for someone, don't call it string 1, right? Because what's string 1? I don't know, right? Later on when you write your code, you're going to have a hard time figuring out what was string 1 supposed to be. But if you call it what it is, like first name, which is a meaningful variable name, then you're good. Okay? So those are the rules. There's no limit on the length of variables. You can go crazy, make them as long as you want, right? And that's that. But try to keep things reasonable. Don't make it too long. Okay? Any questions about that? Just the basic rules. Okay, so those are the rules for the variable names. Some of the other data types that we did. So this is an example of showing some text, right? So let me just go in there and copy this and throw it in there, right? So this is a string my name, and in here I'm going to show you the name is this. So I'm going to run it. Actually, let me just take out this code right here because it doesn't want to repeat. So run it. All right, the name is Alex. If you wanted to, so this endl here tells it to insert a new line. That's what this is right here on the bottom, the extra new line. You can also insert new lines in between or anywhere you want with the \n. Right, \n also inserts a new line, so we force this thing to go on a new line. Okay. What else? Some of the other data types, or the types of information that we can store into our programs, are integers. Integers are whole numbers like 1, 3, 1,000, right? This is an example of how you declare an integer variable. What does it mean to declare a variable? Well, you're telling the compiler or telling the program it's going to be an integer, that's going to be the name for it, And from now on, for the rest of your program, that variable can only be an integer. You can't put a string into an integer. You can't mix the different data types. So declaring is this piece. Initializing is when you make something equal to something for the first time. Okay? So why would you want to do that? If I go in there, and let's say, for example, I do, let's just give it a shot. Int age, right? So I'm declaring it. Declare. And I'm going to do a cout age equals age. And then again, right? If I run this, what do you think this value is going to be that I'm going to show?
Mystery.
Mystery sounds good to me. It's actually 1. All right? Don't count on it for it to be 1. Sometimes it will be a 0. Sometimes it will be a 1. Sometimes it will be some weird number like, I don't know, like this. Okay? So don't count on the variable to be 0 from the beginning. C++ is not that nice. It will just put, so basically you're telling it, this variable is going to refer to some place in memory. Whatever's already in that place in memory is what this variable is equal to initially, which is why you want to go and initialize your variable to like age is equal to 0 maybe, right? This is initialize. Okay, you're giving it an initial value, so now when I say age, you know it's always 0. Okay, it starts at 0. It doesn't have to be equal to 0. You can make it equal to whatever you want, as long as it makes sense to you. Okay? Or as long as it makes sense to the program. So that's the integer, and again, integer is just a whole number. Other data types, floats or decimal numbers, right? Float or double, basically the same thing, except one has the capability to hold longer numbers. Double can hold double as many digits as a float. Okay? And these are some examples of decimal numbers. Anything that has a dot and some numbers after it, right? That's a decimal. So again, declaring, initializing these different variables, showing the variable, okay? You can also have characters. A character in C++ is designated with single quotes, okay? You can also declare and initialize a variable on the same line, like I'm showing right here. Okay, other thing we did was input, right? So before we did input, I told you that you need to have a prompt. Right, so let me go back to this here, and I'm just going to wipe all this stuff out because it's basically repeating the same thing I told you before. And let's say I'm going to go in there and I'm going to make weight. So let's say I'm going to have an int weight, and I'm going to do cin weight, right? Just like that. So this is an example of input. Input is information that goes into the program. I can show you that, and I can do cout. You entered weight, and del. Okay, I'm going to run this again, and now the program is just dark. You don't know what's happening, right? Because you didn't give yourself a good prompt. So that's an example of what not to do. I'm going to go in there, put a 1, and now it tells you, okay, you entered 1. Maybe I should put a little space in there. But I also should tell myself what to do, right? So I'm going to go in there, and this is the prompt, right? Prompt. I'm going to paste in there. I'm going to tell them, okay, enter an integer value. Value for weight. Okay? Now when I run my program, before it was just dark, you don't know what you're supposed to do. I run it. Okay? And I type 1. Right? Enter an integer value for weight. I know what I'm supposed to do and enter it. Okay? Marissa. Come on. Okay? So, any questions? All right. So this is an example of a prompt. Prompt is some information that comes out of the program telling the user what to enter into the program. If you don't have that, they don't know what they're doing. Okay? So that's an example of prompt, right? And you should always show yourself, show what you entered. Show what user entered. Okay? So that's that. Question?
Yeah, I actually do. When would you use a string versus just using a cout for typing? Like what would be the circumstances in which you would use string versus cout?
So this is a string right here.
Yeah.
And why? Okay, well, whenever you see outs, okay, so for example, this is so the question is, when would you use a string in the C out, right?
Yeah.
Well, in this particular case, you only have a string, right? So every C out kind of makes sense to have a string. Sometimes you might want to just, you want to do something like, for most examples, you would want to have some kind of a label for the variables that you show. So even if you're showing, let's say, for example, I want to do this here, so the bottom piece here, I'm going to get rid of the string. Okay, so I'm going to delete this, right? I'm just going to leave weight, right? So what's going to happen is when I run my program, enter an integer for weight, 1, and it will show you 1, but you're going to be like, wait, what's this 1? You want to have like some kind of a string to explain to the user what you're showing.
Well, I'm
So
talking
that's
about
the
the
string.
actual variable where you type in string and identify the actual string. Why would you use that instead of just typing it in your cout?
Because you want to store information that's going to be used later on.
Oh, okay.
Right.
So that's if you're going to repeat it?
Right. So maybe you want if you want this message itself to change to something else, you could ask the user to, hey, please enter a prompt message, right? And then you can see out that. So, okay. Any other questions? Okay. So prompt, telling the user what to enter, input is entering the information, and then you should always show yourself what information was entered, right? And then label things with strings, right? So you entered something, right? Tell the user what they entered. Okay? So that's that. All right. So, and then after that, oh, I showed you a little bit of processing. What's processing? Or just for now, let's just, well, for the last time, we talked about processing in terms of just arithmetic, right? So let's say you have some kind of a variable called weight in pounds, right? And you want to convert that weight, you want to make this thing equal to the other weights that the user entered earlier, but multiplied times some value. And that's an example. This multiplication right here is an example of processing. The computer has to do some kind of a thinking in there. Okay? The processing we're going to do today is another kind called selection. Okay, so this is basically my review from last time. And today what I'm going to do is show you selection. Right, so I'm going to erase all this stuff because it's, again, similar to last time. And what I'm going to do is I'm going to tell you about selection. Okay, so selection is, a way for your program to select only certain lines of code, right? So for example, let's say I go in there and I have an int age, right? And I'm going to make the age equal to 12, okay? And then underneath this thing, I'm going to have cout, you are a minor. I'm going to do an endl in there. I'm going to do another one. This one is you are over 21, endl. And then I'm going to do another one, cout, you are between 18 and 21, right? So what we've learned so far, and from what you've learned so far, if I run this program, what is it going to do? Show all of them. There you go. But I don't want all of them. I only want one of them based on the value of age. So I want to show only this particular message. And this is where the selection comes in. Okay, so I go in there and I say, all right, if my age is less than, 18, then I'm going to do curly brackets. I'll stick to the curly brackets because not to confuse you too much for now. Right? So this is my selection. This piece right here, this is called a condition. Okay? And the less than is the relational operator. Okay? There's also logical operators. I'll show you those in a second. Okay, so we build conditions, which is check to see. What we're doing is check to see if something is true or false, right? And the less than is the relational operator. Okay. how does the computer know to check to see if something's true or false? Or how does it, how is it able to do this? It's part of the arithmetic logic unit, which is part of the CPU, which can do these kind of things. That's the one that can add, subtract, do all the arithmetic, and that's the one that can check to see if something's true or false. So let me show you, for example, and by the way, this true or false business, right, the true or false, which is also another data type called Boolean. Okay, so in the way the Boolean works is, if something is true, it will show as a 1. If something is false, it will show as a 0. Okay, let me give you some examples. So in there, first before I do this, Boolean, right, which is data type for true, false. Okay, other languages actually have specific data type, and in C and C++, it's really just an integer 1 or 0. Okay, but it's still true or false. Okay, so in here I'm going to do cout. I'm going to do 3 is less than 4, right? And I'm going to say here, so you remember, true is 1 and false is 0. Okay? And I'm going to do 3 is less than 4 and L. Okay? In fact, let me put it in parentheses because it's not liking it the way it is. There you go. Okay, so I'm putting it in parentheses, and what I'm going to do is I'm actually going to turn off this code just for a second. Turn this off up to here. Okay, all right. So when I run this thing, what is it going to show me? 1 or 0? 1, right? Because it's true. Run it. 3 is less than 4. I'm going to throw in there and say is, right? Is 1, right? There's a way for you to make it show true or false, and I'll show you that later. But for now, let's just stay with the 1 and the 0, right? So 1 is true. Then the next one is, I'm going to just copy the whole thing. Paste it. I'm going to flip it around. 3 is greater than 4, right? Is that going to be a 1 or a 0? So this one was a 1. That should be a 0. Run the program. There you go. So that's a 0, right? Let's go in there, do some more. Right? So these are actually the relational operators. Okay? So I'm going to go in there. I'm going to do, okay, 3 is equal to 4. This is how you check to see if something is equal. Right? Double equal. Is 3 equal to 4? No. Run it. Nope. Okay. Knows that too. I'm going to copy this whole thing. Paste it. I'm going to throw in a little exclamation in there. Right? Run it again. So this one is 3 is not equal to 4. Right? Is 3 not equal to 4? Yep. Run it. Yep. Gets that too. So these are the basic ones. There's another one. So there's also 3 is, there's also, let me just copy that. Paste. So there's also a 3 is less than or equal to 4. Right? Is it less than 4? No. Is it equal to 4? No. Check. Sorry. Is it less than 4? Yes, it is. Is it equal to? No. But since it's less than, it gets you a 1. Okay? Now if I grab this thing, this other one, copy, greater than or equal, right? So is 3 greater than 4? No. Is it equal to 4? No. So that should be a 0. I run it, and there you go. So these are your basic operators. So the less than, greater, less than or equal, greater, greater than or equal, equal, not equal. So with these relational operators, let me space them a little bit so they're all lined up. All right, so these here are the relational operators. Okay, and I guess you could say this is a condition. Right? That whole thing when you're comparing something to something is known as a condition. Okay, so now you know that the computer can figure out if things are true or false based on this. what we're going to do is we're going to do this selection business. Okay? All right. So I'm going to say if age is less than 18, and if this thing happens to be true, we're going to execute whatever is inside the curly brackets. I could have multiple lines, so I'm going to break this thing into separate lines. UR, cout, A minor. Right? So 2 separate lines are going to happen if this is true. All right. So the next one is going to be you're over 21. So if my age is bigger than 21, okay, I'm going to go in there and I'm going to throw in curly brackets and I'm going to move this thing in it. So it only happens if this is true. And then the last one here is going to be 2 separate things. So it's between 18 and 21. How do I do this? If my age is bigger than, let's include it, or equal to 18. And the other one is, I'm going to throw in curly brackets in there. Inside here, I'm going to do another if my age is less than or equal to 21. And then in there, I'm going to throw in another curly brackets. And then I'm going to put this stuff in it. Okay? So if the age is bigger than or equal to 18, we're going to go in there. We're going to check this. And if this is less than or equal to 21, we're going to go in there. So the age must be between 18 and 21 if they're both true. Question?
And maybe jumping ahead, we can just use an and.
Yes, you can. I'm going to do the end in a second. Okay? So this here is an example of a nested loop. Okay? So what you just brought up was, can I do this with an and? Yeah, there is an and that's the logical operator. So there's logical operator, so logical operator and in C++ is with 2 ampersand signs, right? Ampersand is the end. So let me capitalize this thing. So and, right, is the ampersand. Okay? So I'm going to go in there, I'm going to rewrite the above. Okay, so what I'm going to do is if age is, and I'm going to have to do a couple more sets of parentheses because that's how C++ is. Okay, so I'm going to have to say, I'm just going to copy this, if this, and then I'm going to go in there, I'm going to say, oh, not and, right, and then I'm going to just copy this other one, throw that in here. Right? So if that's true, what I'm going to do is throw in curly brackets under it, and I'm going to show this message. Okay? So I wrote a lot of code. Let me just turn off this piece here real quick. And let's see if it works. So first, for ages less than 12, it should show me this. You're a minor. Yep. Okay. I'm going to change the age to 22, right? So now it should show me this one. You're over 21. It does. Now I'm going to go and tell it something else. Let's go. Well, the only other thing that I can do is between 18 and 21. So let's go 20, right? And now it should show me 2 messages. It should show me this one, and then it should show me also this one. So I'm going to run it. There you go. Twice the same message. Okay, so that shows you that the AND works the same way as a nested if. Okay? Questions? So far, so good? Okay, so now another one. Let me go in there and try to kind of mess with this thing. So I'm going to go and I'm going to bring this one, and I'll leave it there. So I'll just comment this piece out, because I only want to see this message one time. Okay, so now what I'm going to do is I'm going to go and I'm going to give it a negative h just to mess with it. Right? So you can't have a negative h. Okay? I'm going to run it. But it still tells me you're a minor. So no good. How am I going to correct this message? What I'm going to do is I'm going to add an if my age is less than 0, right? If it's a negative value, I'm going to show a message, cout invalid age. Okay? And they'll. Alright. So, if I run this thing, what message am I going to get? 2 messages. I'm going to get this message, invalid age, and which other message am I going to get?
You're a minor.
You're minor also, because the negative is also happens to be less than 18. So if I run it, yeah, 2, right? So I did not eliminate this message. I don't want to see this message if the previous thing is false, right? So I don't want to see this message if the previous thing is true, actually. Previous if or else if is true. And you haven't seen else if yet, but you will right now. So then I go and change this thing to else if, right? And then when I go in there and I run this thing, so this is, this is not going to show, right? Else if only gets checked when the previous is false. Okay, so if this thing happens to be true, we're not even going to bother checking this. Stop there, basically. Okay, run it, and now it doesn't show. Okay, so I can basically reduce how much thinking my computer is going to do, because do I even want to check if the age is bigger than 21? No, because it's already an invalid age. So I'm going to go in there, I'm going to add an else if in there, so to spare the computer from thinking. I'm going to go in there, I'm going to add an else if in this one, to spare it from thinking about that too. So basically just stop it at the first thing that you want to stop, at the first thing that is true. Okay? So I guess let me put a little there, a little something. So if else if chain, right, stops at the first true. Okay? All right. So I'm going to go in there now, and let's say we want to have like a maximum limit for the age. What age do you want to have for a person as the maximum limit? What's the oldest human being?
104.
104? Has anyone looked at it? Let's look it up right now, because I love this part. Oldest documented human being is Jean Comment of France, right? So there's a list of people with whose birth certificates they found, and they could really verify that that's really how old they are. And that's the oldest one that they found, 122 and 164 days, right? So and the funny part is, so we're gonna go with 123, right? But I'm just gonna I'm gonna show you a picture of that person. And I'm just gonna ask you, what do you think she did until she was 119? You don't know? Here's a clue. Hold on. That's her. So she smoked until she was 119, the oldest documented human being in history, as far as we know, right? Smoked every day until she was 119, or right, mostly every day. And the only reason she stopped smoking was because she was too blind to light her own cigarettes, and she hated asking people to do it for her. She also drank wine every day, ate a bunch of chocolate when she got her hands on it, right? So now you know the key to longevity. Okay? So, but
She's French.
she's French, right? So you have to be French too. Sorry. All right.
Do you have to be French, or do you just have to live in France?
Or you just have to live life to the fullest. Okay. All right. So, well, I'm gonna go and I'm gonna give it a cap of. Okay. So now I'm gonna go and do another one. If my age is bigger than 123, right? I'm gonna go and give you the same message as before. If I could select it. All right. Throw that in there. Oh, come on. Paste. Okay, so these are both invalid ages, right? I'm going to even make this an else if too, right? Stop it there. Okay, so I'm going to run this thing, and hopefully it stops at this one. Run it. Yeah, invalid age. Okay, so that's great, but if you noticed, I wrote the same thing twice. Okay, so what I'm going to do is I'm going to rewrite the above code. I love it how it does that. So I'm going to rewrite the above code using the logical operator OR, right? And the OR is two vertical lines. The two vertical lines are shift and that key that's on top of your enter key. Okay? So I go in there and I'm going to do if, and I'm going to copy this one, paste, or this one, there, okay? And then what I'm going to do is I'm going to turn off these two lines right here, or these two if-elifs, or else-ifs, right? And this hopefully should give me the same message. I'm going to copy this message there, right? So both of them invalid age. So first I'm going to test it for negative age. Go with it. And then I'm going to go and I'm going to give it a really big age. I don't remember if I tested it for really big age before, but here you go. Right? That's also an invalid age. Okay? Any questions? Okay, so the way this works, you might wonder, right? You could have this is true and this is true, right? If both of these are true, this is going to show. Then you could also have true and a false. If one of these is true, this is also going to happen. And you can also have a false and true. So if this is true, the whole thing is true, and by the whole thing I mean this, right? The whole thing is true. If one of these is true, this is also true. If one of these is true, this is also true. Okay, the only time this thing is false is when you have a false and a false. Okay, so that's when this thing is false. Okay, so that's your truth table of an OR. Make sense? All right, let me write you the truth table for an AND. Right, the AND was right here. So if I wanted to, I'll throw it right here. So you could have a true, and you can have a true, right? When that's true, like we noticed before, this whole thing is true. Okay. Let me move this back. Okay. Now, if I have a false here, this whole thing is going to be false. If I have a false here, this whole thing is going to be false. And if I have two falses, I have a false and then another false, then the whole thing is false. Okay, so it's only true when both of them are true. It's false for everything else. Does that make sense? We're good? That's selection. That's basically all there is about selection. Okay, and this is how you make a car program itself, a car drive itself. With just a bunch of ifs and elses, and yeah, if it's this close to something, maybe stop, right? That kind of stuff. All right, so let's see what else I want to tell you. So go back to the week 1. Okay, so let's see what I have in there. If I covered everything I wanted, it's just another lecture. Basically the same thing. What else do I want to tell you? Okay. So I covered the selection. I showed you the truth table. I showed you a little example. Let me show you a couple more things, and then we're done for today, and you can get started on these things. And that is, let's see if I have... Okay, so the one other thing I want to show you is this modulus operator, or modulo operator. Okay, so that's your selection business. And by the way, this variable here could come from the user, right? You can go in there and say cout, please enter your age, right? And then I can go in there and say cin age, and then now it's going to go based on whatever age I give it, right? So I go in there, I run it, okay, enter your age, -1, invalid age, run it again, enter an age, 333, invalid age, run it again, enter an age, 16, you're minor, run it again, this time 22, run it again, you're over 21, finally, let's go 20. Okay, so what did I do? I ran my program a bunch of times, and by the way, this is how you should be testing your selection programs. If you're gonna have one if, and then another one, and then another one, and then another one, you have to run your program for every possible case, right? I gotta run it for every one of them to make sure that it works, because a lot of times you would think it works, and it doesn't work, okay? And those will be the logical errors. Those are actually harder to detect than your syntax errors. Syntax errors, you forgot a semicolon, you run the thing, and it's just broken, it doesn't work. Oh, it's at line 52, oh, whatever, something. Right, it's at line 83, right? Put a semicolon, easy fix. But then your program works, your program, you know, you run your program and it works, and then it shows you some weird result. Or maybe it crashes. Those are harder to decipher. Those are the runtime errors or logical errors. Okay? So, that's as far as selection is concerned. Okay? Now, what I'm going to do is, I'll leave that in there. Actually, I'll just turn off this piece of code because I hate entering things into my programs until they're all the way done. So for testing purposes, I won't even do the input. Most of the times, I'll just change the numbers right in here manually. Okay? So, and the reason for this is I might run my program a whole bunch of times. Sometimes I would run it many times for the same number. I don't want to go in there and enter a number, enter a number, enter a number. I tested it like 12, 13 times. I don't want to go and enter 12, 13 times the same number. I would just leave it as whatever I want it to until it works for that number. Then I'll go and test it for the other one. Then when it's all the way tested, then I'll enable this thing, right, so that the user can go and enter their, information. All right, so that's one thing. The other thing that I want to show you is the modulus or modula, or different people call it different things, right? I kind of remembered it as the modulus operator, right? Modulus, modulo, also known as the remainder, right? Also known as the percent sign. Okay? And this is not division. Don't confuse this thing with a division. So let me show you. So if I go in there and I do a cout, 3, I'll put it in quotes, 4 is divided by 3, right? I'm going to go in there and whoops, I should have shown it. So 4 divided by 3, there. I'm going to make it equal to something, semicolon, run it again. So 4 divided by 3 is 1 because, by the way, notice this is, before I even get to this here shows this, right? Which is not exactly what you think, right? 4 divided by 3 is not 1, right? It's 1 point something. Okay, why is it not showing 1 point something? Because that's just the way C++ is. What you have to do is, let's go in there and do 4.0 divided by 3.0. Okay? So 4.0 divided by 3.0. Okay, so we're not even doing the modular yet. Take that out, put it under. Okay, so this is an example of one of the, I would say, I don't know, maybe flaws of the language, but integer division. So when you have one integer and you're dividing it by another integer, C++ will automatically assume that you're looking for an integer.
Sorry.
All right. So integer division, when you have one integer divided by another integer, the results will come out to be an integer. Okay? If you wanted to, you can tell it 2 decimal numbers like this, and then it will show you an actual decimal number. Okay? So beware of that. Any questions? All right, so be careful because you could have like some really long equation. Let's say you're calculating the volume of a sphere, and there's like a 4 divided by 3 in there, or I don't remember if it was 3 divided by 4, and then it doesn't give you the right answer because it's doing integer division. Okay, so no good. All right, so just be aware of that. Now let me show you the modulo operator. Right? So let's do this. I'm going to keep with these here. So this one here shows this. Okay. So the next thing is the remainder operator, or the modulo, the percent thing. So I'm just going to grab this first piece. I'm going to copy it. So you kind of know how it works already. All right. So you know that this thing is going to show you this. All right. Oops. Grab the comments. Okay. So now what I'm going to do is I'm going to do the modulo operator, and it's going to look like it's the same thing. All right. I'm going to go in there and do a percent. All right. And you're going to see the results. Actually, let me just turn off this so you don't see it. All right. So I'm going to run this again. And it looks like it's the same thing. Okay. Let me go to the next one. 5 and 3, right? So I'm going to do a cout, like a little separator in there so it looks pretty. All right, \n in there instead of the and l. Okay, so I'll do, I'm going to copy both of these. I'll erase this. So I'll copy both of these. And I'm going to change this to 5. Okay. All right. So I'm going to run it again. Now it's getting weird. Okay? So 5 divided by 3 is still 1 because it's doing the integer division. It's cutting off that decimal piece. Okay? But what about the 2? Okay? Well, the 2 is what remains when you divide 5 by 3, right? There's a 2 that remains. So basically the question you want to ask yourself is this. How many times does 3 fit into 5? How many times? 1. Okay, so the remainder is 5 minus 1 times 3, which is 2. Make sense? Let's do another one. I'm going to grab this piece again, and I'm going to put it right here. I'm going to do a 6. And I'm going to, I'm going to ignore the division from now on because you already know that the percent is not a division. I'm going to change this to a 6 modulus 3. Okay? So what's the remainder now? 0, right? So let's ask ourselves the same question. I'm going to copy this piece. All right? How many times does 3 fit into 6? How many times? 2. Right, so the remainder is, I spelled remainder wrong, can't help myself, sorry, is 6 minus 2 times 3, which is 0. Okay, does that make sense? That's the remainder operator. Okay, I'm going to do a couple more so that you can see it, and I'm going to turn off the division example for now. Turn off this, whoops, turn this off, turn this off. All right, so you can see the 3 of them side by side. Actually, I'll turn this off too. Turn this off too. Run it. All right, so notice what's happening. 4 modulus 3 is 1. 5 modulus 3 is 2. 6 modulus 3 is 0. I'm going to do a few more. Okay, so since you already know how it works. All right, so I'm going to do a 7. I'm going to do 8. I'm going to do 9. 7, 8, 9, right? What do you think these numbers are going to be? Good guess. 1, 2, 0. So the moral of the story is the remainder. So let's say I have some kind of a magic number or whatever. Let's say I have a huge number with underscore. Huge number modulus 3. What do you think this is going to be equal to? There's three possibilities. Is either 0, 1, or 2. Okay? Any number. I can feed it any number. Modulus 3 is going to be either one of these three numbers. Okay? This is something used in hashing. Okay? When you do data structures later on, you're going to learn about hash tables and dictionaries, and it's actually also used in encryption. Okay? And if you take the Python class I teach, I'll show you how to do brute force cracking a password and that kind of fun things. But not in this class, because this class, I mean, C++ is not very good with strings and that kind of things, and it's not a very user-friendly language. Anyway, so this has lots of applications beyond just what you're seeing right now. And one of these applications, other than dictionaries and hashing and encryption, is to check to see if something's odd or even, right? Check to see if something is odd or even. Any ideas how we can do that with the modulus? Watch. Yes, so if I do huge number and I do modulus 2, right? That's going to be either 0 or 1, right? If it's 0, what does that tell you? It's an even number. If it's 1, it's an odd number. So in case you don't know the even and odd, 2, 4, 6, 8, 10, right, etc. These are even. And then if you have 1, 3, 5, 7, 9, right? These are examples of odd. Okay? So how would I do an if? Let's say I'm going to go in there, I'm going to do int number. And by the way, this thing only works with integers. Don't try to feed it floats or decimals. It's going to throw a fit at you. It's not going to like it at all. Okay, so int number, I'm going to do cout. Please enter a number. Okay, and then I do cin number, and I do cout. Whoops, not cout. I'll say if number modulus 2 equals 0. I'm going to show you cout. The number is even. Okay? So notice one thing I did here. I kind of broke the little rule that I had from upstairs. Before I kept putting curly brackets around everything, but the reality of things is you really don't have to have curly brackets if you have a single line. So if there is a single line in the if, you don't need the curly brackets. Okay? And I kind of hate showing this because as soon as I do this, people start messing up the ifs by forgetting the curly brackets, because sometimes you have multiple things and you're not including everything inside the if because you forgot to start curly brackets. So if you want to put curly brackets on everything, please do. Okay? But if you're confident you got it right, just skip the curly brackets. So I could go in there and rewrite a lot of these things. Even if I had this nested if, I could get rid of this curly bracket, I could get rid of this one, I can get rid of this one, and this one. It will still work the same. Because there's only one thing inside of this if, which is this if, and there's only one thing inside of this if, which is this cout. So you can really reduce your code by quite a bit of curly brackets. But don't confuse things, okay? All right. So this is the number is even. And then finally, let me show you an example. So you already saw the if and else if, right? So the number is only going to be even or odd, right? So the only other thing that could happen is this thing is going to be odd. So what I'm going to do is I'm going to say else, right? And then under the else, I'm going to do, let's do curly brackets, right? I'm going to say cout, the number is odd. And okay? So the else, notice it does not have any condition. So you cannot do, I don't know, else number modulus 2 is not equal to 0. It's not going to like that because you can't have a condition for an if. I mean an else. Okay, so there's no condition in there. Okay, you could do an else if you wanted to do this. You could do this as an else if. Right, that would work. So let's try it. So I'm going to run it like this. Please enter a number 2. The number is even. Run it again. Please enter a number 1. Number is odd. Okay, now I'm going to erase this just like that. Right? So the else happens automatically when the previous if or else if is false. Okay? So if this thing wasn't true, this whatever's inside the curly brackets of the else, and again, I don't need curly brackets even, but I'll leave them, is going to happen. Okay? Please enter a number 1. There you go. That works too. Any questions? Now you know how to do odd and even. Now you know about the modulus operator, also known as the remainder, also known as the modula, right? And you also know about selection, which is these ifs and else ifs. You know about the relational operators, which help you build conditions, which is, condition is something that we're checking to see if it's true or false. So, let's have a look at what are your assignments for today. So, week 1, go to the bottom. Okay, you're going to have precision area perimeter. Okay, so there's a little quiz which has to do with the chapter 1 Savage, which is this little PowerPoint here. So all the answers for the quiz are going to be in this chapter 1. If you don't like your score on the quiz, I have set it up to unlimited attempts, multiple attempts with the high score counted. So you take it one time, you don't like your score, take it again. It will show you the answers, so try not to cheat. Okay? Okay, so, all right. So what are the assignments you have to do? Voting. Right? What are you going to do? You're going to ask a person 3 things. You're going to ask them, let's just change this. Because you don't want to use strings in Python and this. So let's do this. I'm going to edit this. I'm going to change it. Are you a citizen? I'm going to say 1 for yes, 2 for no. That way they entered 1 for yes. Right? And I'm going to do the same thing for this one. Again, I'm avoiding strings as the plague for now. Okay, 2 is no, right? So they said, so if this is the case, right? So if they entered an age, a good age, well, let's do this. Let me extend this thing. So sample run, that's 1, but there will be a few more. So I'm going to get this one. Let's say, all right. So this one, let's say I'm going to go in there, I'm going to give it, there are 20. So first of all, the rules for voting, rules to vote must be, well, I'll put them like 1, 2, 3. All right, so it has to be, must be citizen, must be over, 18? And must be registered. Okay? So if they're over 18 and if they're a citizen and they're registered, you tell them, congratulations. Congratulations. You can vote. Okay? But there's more possibilities, right? And remember how you're supposed to test every single one of them? Or here's the other ones. So other than this, you're going to go in there and you're going to do, all right, I'll copy this whole thing. Copy this there too. Okay, so if they say, all right, you are, let's say they give you a no to this here, okay? then the result is going to be, sorry, can't vote, and then you're going to give them something like, you are not registered. Okay, that's one of them. The other one, I'm going to copy this whole thing. Now this one is going to be a 2 and a 2 here. So now I'm going to tell them, sorry, you can't vote. The other message that I gave, and this one now is going to be, you are not a citizen. Okay, so you're not a citizen, you're not registered. You give them both messages. That's how the program is supposed to work. Okay, you're not going to stop them. You're just going to let them enter all 3 things, and then show them the 3 messages if there's 3 messages to show. The 3 messages will be this next one, if they're all 3 false. So I'm going to grab this whole thing here, copy it, paste it in there. All right, so the next one is, now I'm going to make it an age of 16 or something, and these are two no's, and I'm going to tell the user, you are not old enough. Okay, so how many times do you have to test your program? 1 time for this one, 1 time for this one, 1 time for this one, 1 time for that one. Okay? Let me give you a hint. All right? Even though some of you don't like that many hints. So what I'm going to do is, I'm going to go in there, I'm going to do this, and I'm going to go in there, and I'm going to put it, at the end. Okay, so this is hint P7 hint. Okay, so I'm going to, the user, let's say user enters these, right? So it's going to be an int, I probably have age already. Yeah, I already have age. Okay, I'll make it a capital H. Age, right? Let's say is equal to whatever, 23. I'm going to say citizen is equal to 1, right? And you could put a little comment in there, so you tell yourself, okay, 1 is yes, 2 is no, something like that. And then you're going to do int registered is equal to 1, right? Same business. 1 is yes, 2 is no. Okay, so the first one will be, let's say if they can vote. So if my age, let's throw in extra parentheses. So if my age is over, what do we say, 18? Greater than or equal to 18. And then, and my citizenship status, citizen is equal to 1, is a yes. And my registered is equal to 1, right? And you have to put them in parentheses, otherwise it doesn't like it. It's just rules of the language, that's the syntax. And then in here I'm going to say, all right, see out, congratulations, you can vote. Okay, so that's that. Okay, so that's the you can vote case. The other one is sorry you can't vote, is basically going to happen when this thing is false, right? So I'm going to start with an else, right, which happens automatically when the previous thing is false. I'm going to throw in curly brackets in there. I'm going to say see out, sorry, you can't vote, and I'll add a few extra messages. So this one happens automatically, you can't vote, and then I'm going to do, all right, I'm going to do if my age is less than 18, I'm going to say a message, see out, forgot the new line, see out, you are not old enough, okay? And a new line in there, okay? And then what you have to do is write a couple of more ifs, write the other 2 ifs. Okay, best thing you should do is don't even look at my hands. Just solve this on your own. It's kind of too late because I showed you this. Okay, but as an online class, I don't want somebody to get like totally lost. Okay, so that's your P7. Okay, I'm going to save it wherever the save button is. Okay, and then what I'm going to do is I'm going to go to the next one, P8, hide message. Okay, so the hide message goes like this. You already know you had one program where you had to calculate height. Did we do that already? No? All right, well, you do it now. The user enters two things. They enter their feet, and then they enter their inches. Then your program calculates their total height in inches. Whoops. And then the next thing you're going to do is, there's a couple of messages that are going to show. One is, if they're over 72 inches total, you tell them something they're tall. If they're between 5 and 6 feet, you give them a second message, something like your average. And then if they're less than that, if they're less than 5 feet or 60 inches, right, you tell them you're too short or something, right? Just insult the user, I don't care. Okay, height shaming. Any questions? You want a hint for that? Yes? All right. I aim to please. So P8, hint. All right, so we have int, well, we'll just go with int, feet, inches. All right, I'm going to make my feet, and I can ask the user to enter these. Let's do it. Cout, enter feet. All right, oops, feet, cin, feet, cout, enter inches. All right, cin, inches. Okay, and then I can have another variable. Let me declare it up here. Total, I'll just call it total. Total is equal to feet times 12 plus inches. Okay, and then you're going to have some messages like if total is bigger than 72, you tell them some kind of a message like cout, I don't know, you are too tall or something. Okay? And then you have to write the other couple of ifs. Okay? Write the other two ifs or else ifs. It's up to you. Okay? I would make them else ifs. Questions? Should be good. Okay? That's the P8. And then what else we have? We have letter grades, right? So what you're going to do is you're going to ask the user to enter their grade, right? And then you're going to calculate their grade in percent they're going to enter. And based on that number, you're going to figure out their grade. So let's give you a hint on that too. Okay, so P9 hint. Okay, so let's say you have an int grade, right? You tell the user enter grade, right? And then you do cn grade, okay? And then if their grade is between, and let's say we want to make sure that it's between, we'll tell them between 0 to 100, right? Okay? Grade in percent. Okay? They're not going to enter the percent sign. They're just going to enter a number. What is that number going to be? Between 0 to 100. So if my grade is greater than or equal to 90 and my grade is less than or equal to 100, I'm going to show one message. And again, you got to throw in extra parentheses because that's what C++ wants. Otherwise, we'll break on you and not work the way it wants, the way you want it to. Okay? So I'm going to go in there and I'm going to say cout, you have an 8. Oops, let's put it in quotes. Oh, let's say I want to show the 8. So I'm going to do backslash quotes. That's how you show quotes inside of quotes. A backslash quotes, and then another quotes in there. Okay? So that's that one. I'm going to throw in a backslash n. So the backslash is an escape character. It tells it there's going to be something after that. Sometimes that something tells it to do a new line. Sometimes that something is like a quotes that you want to show. Okay? So that's an example for the grade. Let's have a look at it. So please enter a number. What was this one? I don't even remember. So enter feet. Feet was, I don't know, 7 feet, 0 inches. All right, you're too tall. Now enter a grade in percent. I'm going to give it 96. And now it gives me an 8. Okay? Any questions? P9. That's the end of the hint. Let's see if there's anything else. There's another one. Precision, area, and perimeter. This one is not even a selection one. It's a practice for you to round numbers. So I'm not even going to do a hint on this. So this one is enter a height and a width. You have to show the numbers in this format. Notice that I'm telling you, please, the program must run exactly as I show it. So that means that they enter 2 digits here, they enter 1 digit here, you're going to show 2 digits here, 1 digit here. This result is going to be as 1 digit shown, right? And then the perimeter is going to be shown like this, 2 times whatever they entered, and tested with these numbers that I have. Don't even bother trying something else. Just enter the ones I have so that you know if you're getting the right results. Okay? The trick for this is to use this. There's a setf iOS fixed. It will look better on your screen. There's a cout.setf iOS show point. You're going to do this one time before you start using the precision. Cout precision right here tells it to round the number to 1 decimal. So I'm going to do a cout precision. Let me just show you. I got it. So cout setf P10 hint. All right. So I'm going to do cout setf, and then it's iOS input output stream, and it's fixed. That's that. I'm going to copy this, put it under. Then the next one is show point. You have to do both of them. Okay? And then the next one is precision. So let's say I have a float a num is equal to 1.234. Okay? So if I do cout, and let's say I'm going to go in there, I'm going to do a num2 is equal to 4.567, so you can see how it's done. So first I'm going to do a num equals a num, okay, and endl. I'm going to do the other one. This is 2. Okay, so if I run this code, I'm going to have to enter some stuff here first. All right, 1, 1, 1, 1. Okay, so it shows them with some extra decimals even. Okay, but I don't want to see that many. So what I'm going to do is I'm going to go in there and I'm going to do the cout.setf, and how's it go? Oh no, it's just precision, and I'm going to go give this one a 1, and then I'm going to put a semicolon in there, and then I'm going to go copy this, and I'm going to put this other one is going to be set precision 2, right? So in fact, I should have done this. Let me do this. I'm going to undo this so you can see it one time like this. All right, and then under it, I'm going to do it like that. So I run it one more time, and 1, 1, 1, 1. Right? This one is rounded to 1 decimal. The other one is rounded to 2 decimals. Questions?
Do you put that under the decimal every time you have a decimal? The CO precision?
As long as it's left like this, watch. I'm going to grab this thing now. I'm going to copy it. And if I put this a num now, these are both going to be formatted with 2 decimals. So everything under it is going to be formatted with 2 decimals. So I'm going to run it again.
Until you change it.
Until I change it again. All right? Okay? There's actually an easier format to use using C with a printf, but I'm not going to show you that so I don't confuse you with too many things. Okay? Just use the precision. So it's just an exercise of, massaging your output to look the way you want it to look. What else? Oh, one more thing. So one of the online students was asking me, notice how C-line always makes this main.cpp. If you're using code blocks, you don't care, right? But how do you save this, right? Let's say this is P-1, or let's do this. This is P100 or something, right? And how am I going to save this? Well, it's main CPP here, and you're going to have to go and look for that main CPP file somewhere. If you're working in C-Lion, you can just test the program, make sure it works. All right, this is all my output. I'm going to grab all this stuff here, all right, because that's what I'm supposed to do. I'm going to put it on the bottom of my code, all right, to show my test run. I'm going to save it. I'm going to select all, Control A. I'm going to copy that code. I'm going to go into my Sublime editor. If you're on a Mac, I suggest Sublime. If you're on Windows, I suggest Sublime. Okay, there's other ones, but go with the same thing I'm using. All right, that's my code. I'm going to paste it all in there. No color for now. I'm going to copy my file name. I'm going to go File, Save As, and I'm going to put this thing, let's say, on the desktop so it's easy to find. Use that file name, and that's where you file us. And this is what you're going to give me. You're going to give me your CPP file with all the code, and then you're going to show me your test run at the bottom. Don't forget your comments on the top. Right? Change the date, change the description. Right? Oops, what's today? 21. Right? So is it 22 now? 22. Description is, I don't know. This is selection. Okay? For your programs, don't just give me these one-liner descriptions, because that doesn't tell you a whole lot. Okay? Just copy the description from the assignment. How would you do it? Let's go. Let me show you. So let's go to the previous one. This, right? This is my description. I'm going to grab this whole thing here. I'm going to copy it. I'm going to throw it in Sublime like this. Or C-Lion, wherever, right? Throw all that stuff in there. You can get rid of the extra spaces, right? So it's, you know, saves some real estate. All right? And then maybe put them on the same line. One rule is not to exceed more than 80 characters per line. Right? Notice Sublime right here, it shows me there's 59. Don't exceed more than 80 per line because it becomes hard to read. Right? If you have a newspaper, you know, article and you're reading it, the paragraphs are not like stretched across the whole page. They're narrow. It's easier to read. Okay? So that's one of the code guidelines that, you know, I would like to see. I'm not really enforcing it that much, but just it's good practice. Okay, so that's that. Any questions? I'm going to copy this whole thing, throw it in my C-Line so that I can save it for you later. That's the lecture. Okay, we're good? Okay, question?
Well, if I write like a CPP file in Sublime, can I run it through like the command line?
Yeah, you can run it from the command line. In fact, you can, but it's more difficult. Yeah, I have to show you what's the syntax to run from the command line. But actually, there's something neat about Sublime. If you have just output, and you're on a, let me just try to select all this so I can show you. Sublime is a really neat editor. By the way, notice it automatically figures out my code is C++. And if you have set up the compiler the right way, cout, hello, right? It will do the output, I think. Watch, so I'll do Control-Shift-B. There you go. Shows you that right in there. It won't work for input though. If you start doing input, it won't work. Then you have to run it from the command line, all that stuff. But it's actually, you can quickly compile your code in Sublime too. Watch, if I get rid of the semicolon and I do Control-B, it highlights, it will basically show you the error that shows up in the command line. So that's neat if you're doing Java.
Okay.
Yeah. Okay? In Java, you're not going to be able to run them. You'll be able to just compile them, just like this. Any other questions? All right. So, I am going to upload this lecture for you. I'm going to upload the video for you. And that's all I have for today. Thanks for coming. And if you want to get started, we still have like 20 minutes, about 20 minutes before I get going. Yeah, let me come over right now.